forecasting tool I want to cover in the classroom is called simple moving average. The reason why it's called simple, because it actually happens to be simple. Okay? So suppose you want to apply a 3-month moving average. All it is you take the previous 3 months of data, okay, and then find the average for that. Now again, no one's going to tell you use 3 months. We'll talk about how to decide on that later on. But a 3-month moving average simply means take the previous 3 months of data and find the average of that. Okay? So best way to understand this is you can go to your handout. So here we go. January, February, March, April, May, and June. Here's data for the last 6 months. Here's my demand data. So it's 12, 11, 15, 12, 16, 15. I'm going to apply a 3-month moving average, and just for the sake of practice, I'm going to apply this 3-month moving average across the entire data set. I repeat, even though the question is, what is the forecast for July? Just for the sake of practice, I'm going to apply this 3-month moving average across the entire data set, which means for me to apply a 3-month moving average, I need at least 3 data points, which means I'm going to go to the month of April now, and I'll take the previous 3 months of data, which will be 15 plus 11 plus 12, all over 3. Okay, so it's going to be 38 over 3, which is nothing but 12.67. Then I go to May. Again, at any point you have any questions, stop me. May. The previous 3 months would be month of April, the month of March, and the month of February, all over 3. It's again 12.67. Let's go to June. The previous 3 months would be the month of May, the month of April, and the month of March, all over 3, which should be 43 over 3, which should be nothing but 14.33. Finally, July. The previous 3 months would be 15 plus 16 plus 12 over 3, which is nothing but 14.33. So all we have done at this point is we have data for the previous 6 months. In this 3-month moving average, which is a type of a time series forecast, we are using the past data, meaning the history is a good guide in terms of what's going to happen in the near future. That is the assumption we're going to make in a time series model. And again, I've still not explained to you guys why 3 months, why not 4 months, why not 2 months. We'll talk about it a bit later on. At this point, I'm applying a 3-month moving average, meaning I just need 3 data points, so in order for me to forecast for July. Now, one drawback with this procedure is that I can only forecast for the next time period. Okay, in fact, there are 2 other forecasts we'll cover in the classroom now, and for all the 3 forecasts, while they're very popular, they're very good, they give a good indicator. I'll explain what good is later on. But for all the 3 forecasts we're going to do in the classroom, the first 3 ones, the biggest drawback is that I can only forecast for the next period. In our case, happens to be the month of July. I cannot forecast what's going to happen in August, September, October, etc. That's the reason why this is a forecasting tool that's also referred to as a short-term forecasting tool. It's a short term, not a long term, not a medium term. It's a short term forecasting tool where I'm just able to forecast for the month of July. Any questions? Again, at this point, I have paid no attention to the fact that data might have some trend, or data might have some cyclical issue, or data might have some seasonality issue. I've totally disregarded that for time being. We'll come back and then ask the question, if the data has any seasonality or trend, how do I revise my existing forecasting tool? At this point, I'm going to cover the forecasting tools. We'll come back and revise them later on. We'll also answer the question, why 3 months? Or how do I know I have to apply a 3 months? Just because textbook tells you that, that's okay, no big deal. Why not 4 months? Why not 2 months? Okay, so this is an example of a simple moving average forecast. So I go back to the problem number 2. In fact, part A says, use a weighted moving average with weights of 0.6, 0.3 and 0.1. So again, the example is a 3-month weighted moving average. The 3 weights are 0.6, 0.3, 0.1. Please note that the weights do add up to 1. Point number 1. Point number 2, the assumption is that the highest weight is given to the most recent time period. I repeat, the highest weight is given to the most recent time period, in the sense that you tend to trust the most recent time period compared to time periods which are not more recent, right? So go by the same problem, January, February, March, April, May and June. Data is 12, 11, 15, 12, 16, 15. Again, I'm going to apply this for the entire data set, meaning I'm going to go to the month of April now and I will apply the highest weight to the month of March, which would mean 0.6 times 15. 15 comes from March, plus 0.3 times 11. 11 comes from data in February, plus 0.1 times 12. 12 comes from January. And the important thing to note is you divide by the sum of the weights. You divide by the sum of the weights. So in our case, happens to be 1. So it's 9 plus 3.3 is 12.3, 13.5. Let's go to May.
Sir, can you repeat the weightage once again, sir?
The weights given to us in the problem are 0.6, 0.3 and 0.1. The assumption is that the highest weight goes to the most recent time period. So if you are the month of May,
So,
I'll give the most highest weight of 0.6 to data in April, plus 0.3 to data in March, plus 0.1 data in February. And I divide by 1. So in this case, 7.2 plus 4.5 is 11.7, 12.8. Let me come to June. 0.6 times 16 plus 0.3 times 12 plus 0.1 times 15. So 9.6 plus 3.6 is 13.2, 14.7. I know many of you folks probably use Excel, so it took you like 1 microsecond. Sometimes you just have to do by hand just to get a feel. Just to get a feel. Small problem. Otherwise, Excel gives you a very, it misleads you. It does, I mean, you really have to get your hands, how would I say, dirty, if you will. That's the reason I want to take you guys back to your wonderful high school days. Remember your high school days, people? Life was so much of fun, right? Get up in the morning, Breakfast ready. Go to school. Go with lunch. Come back in the evening. Snack ready. Night dinner ready. Okay. No bills to pay. Nothing to worry about. The only thing I'm sure many parents require is do your homework. The good old days, you had to do by hand, right? So while I'm okay with having you guys use your laptop, sometimes you just have to do it to appreciate the tool. Again, if you still insist on using a laptop, that's fine. Because I'm sure many people, 2 seconds, cut and paste the formula, boom, it gives you a number. You're happy looking at me. Why is this guy spending 5-10 minutes? I already have the answers all done. Sure. July. 0.6 times 15 plus 0.3 times 16 plus 0.1 times 12. So it's 9 plus 4.8 is 13.8 plus 1.2 equals 15. Now remember, at this point, I still not answer the question, how do I pick these weights? We'll talk about it later on. Why only 3 weights? Why only using a 3-month weighted moving average? Why not 2 months? Why not 4 months? We'll talk about that. Any questions on this tool? Any questions? Yes, please.
You told that we can predict only 1 month.
Correct.
But if I continue the formula using, once I have July, I can predict August using July, June and May.
But July data you don't have, right?
But I can predict if I continue this algorithm.
No, but July's actual demand you don't have. This is just your predicted data. Until I have the actual demand for July, I cannot predict for August. That's the reason why you can only predict for the next time period. That's a drawback with this procedure. But anyways, it's still a very popular one. Yes, sir. Go ahead. Why are you dividing by?
1.
I divide by the sum of the weights. In this case, happens to be 1. Suppose your weights are 5, 4, and 3. What do you do? The weights are 5, 4, and 3. How do you approach it? So, you don't actually use 5. You're going to say 5 over 12, 4 over 12, and 3 over 12. So for the month of July, as an example, I'm going to say 5 times month of June data plus 4 times month of May data plus 3 times month of April data all over 12. So you want to ensure that those weights all add up to 1. That's the reason why I'm using 5 12s, 4 12s, 3 12s, so they indeed add up to 1. 12 happens to be a common denominator. That's the reason